they've got the new Hangouts. Okay, so everyone, so we are now live in 3, 2, 1. I apologize, everyone. There's a whole new way of doing Hangouts now, and we're still trying to figure this out. So, well, hi, everyone. My name is Fraser Kane. I'm the publisher of Universe Today, and this is a special episode of the Weekly Space Hangout. This week, we are dedicating our entire show to Comet ISON, and this is sort of part of a larger project, actually, we're doing with the Discovery Channel. They're doing a special, Discovery Channel, Discovery Science in the United States and Discovery Channel Canada are doing a big special on Comet ISON that's going to be broadcast on television on December 4th, 2013, and as part of that, we're going to be incorporating our Space Hangout into this and sort of the show we're going to be doing today, and a lot of other really interesting stuff. So keep your eyes peeled for that, and we'll be giving you more information. So joining me for this very special episode of the Weekly Space Hangout, we've got David Dickinson.
Hey, I'm ready for all ISON all the time this month.
All ISON. Well, it's been all ISON all the time for you for months now.
Even more so, I think.
Yeah, this month. Yeah, this is going to be the big month. I know people are getting really excited about ISON. We're all getting deluged with emails and calls and lots of comments on all the posts and a lot of stuff that we want to clear up. So this has been fantastic. We got Dr. Nicole Gallucci.
Hello.
Hey, Nicole.
Oh, wait. Here we go.
This is great. So,
very cool.
This is cool. So you're going to be showing us how a comet is, how to make a comet.
How to make your own little comet you can hold in your well-protected gloved hands. Yes,
if you have a chemistry department at the university that you can raid.
Or you can just go buy dry ice.
Just
don't ever put it in your freezer. If you put it in your freezer, it will freeze your freezer and break it.
Yes. I discovered you cannot buy it in the grocery stores in this town, unfortunately.
Really?
Yeah, but most places I've lived, you can buy dry ice in the grocery store. So.
But you can buy it. Okay, yeah, we used to get it in like ice cream cartons. We get a box with a bunch of ice cream and there's some dry ice in it. So this is going to be great. And we've got Dr. Pamela Gay.
Hello.
My co-host on Astronomy Cast and the director of CosmoQuest, professor at Southern Illinois University, Edwardsville. And you, of course, know all things comets, and so you're going to be helping us out today as well.
I'm bringing the science.
Bring the science. All right, so as I mentioned, it's going to be all things. It's going to be ISON all the time today. Oh, I lost my my overlay. Let me bring myself back.
Oh no.
Yeah. Right. So it's going to be all things ISON all the time. Now, there's even cooler is that we are filming this, recording this, broadcasting, hangouting this live from the H.R. MacMillan Science Space Center in Vancouver, British Columbia, which is my hometown, and this is my local planetarium. So this is the one that I came to as a kid, and it's really awesome that we're able to do this here. And so hopefully we're going to get some cool shots of the planetarium later on today. So as always.
It's cool how you have a coronal mass ejection right beside your head.
Just coming out of your ear.
Is it really?
Yeah.
Did I get that looked at? But it's well, this is what Comet ISON is going to be facing, this terrible environment of the sun in the next month. So we thought it would be really appropriate. But we'll be bringing some pictures of ISON as well. But now, as always with one of our live broadcasts, you can interact with us, and so there's a bunch of ways that you can do that. So the first thing that you can do is if you're watching this on the event page on Google+, you can post a comment there, and we'll try to keep track of that. If you're watching this on YouTube, you can post any comments or questions that you might have on YouTube, and we will catch that there. And as always, we appreciate you raising the quality of the discussion on YouTube. And then the last thing is if you want, you can tweet at various people, and maybe someone will get that. Probably not, though. So the safest place, if you're watching this embedded over on CosmoQuest, or if you're watching this on Universe Today, places like that, you're going to want to click on the YouTube and watch it live on YouTube. And then if you want to ask some comments, you can do that there. Great. Okay, so now we're going to get into the actual content of this episode. And just one warning, Kelly Peckham is here from Discovery Channel, and she's the producer of the episode they're doing, and she may very well want to jump in and ask some questions of the people. So if you see someone jump in from time to time, that's what's going on. Okay, great. So let's get on with the actual show here. So first, I think, David, I would like to get a bit of a history lesson on Comet ISON. Where did it, who first discovered it, and where did we sort of find out about it, and and sort of
Yeah,
know that it was going to be a very special comet.
We've known about this comet for over a year now. This is kind of unusual that we've been tracking something. They knew that they had found something interesting on September 21st of last year when ISON stands for the International Scientific Optical Network. It's a telescopic network over in Russia that identified this comet. It was an Artyom Novichonok and Vitaly Nevetsky that were the two scientists that observed this comet and reported it to CBAT, the Central Bureau for Astronomical Telegrams. And we knew we found something interesting when we see something that is relatively bright at a very far distance out there. That this is kind of the same kind of situation when they discovered Hale-Bopp back in the mid-90s. That they found a comet that was very distant, but we know if it's intrinsically bright at discovery, that it's going to be a very bright object. And it got really interesting when we started looking at the orbit and discovered that it is a sun grazer, that it's going to be coming in very close to the sun. It's not going to be loitering in the outer solar system like a lot of comets we discovered. There really hasn't been a sun grazer quite like this one. It's not a Kroon's group sun grazer per se. It's not going to be close enough to do that, to fall in that category of comets. But it's intriguingly close to some other comets that were very bright and great comets, like Ikea-Siki in the mid-60s. There was some preliminary interest that it was related to the Great Comet of 1680. We know that that's not the case right now, but it's got a lot of the same characteristics as a lot of those types of comets.
Terrific. What was the last big bright comet that you all got a chance to experience? Who was able to see? I'm gonna mess this up. Hyakutake. Did I get that right?
I saw it. Yeah.
Pamela, did you get a chance to see Hyakutake?
Yeah, that one was actually extremely memorable for me. I was a grad student working out at the University of Texas's McDonald Observatory at that point, and the very first night I ever observed out there, the person who was teaching me to use the telescope was like, "You've just got to make it to 5 a.m." And I'm like, okay, I think I really need to make it till sunrise. But at 5 a.m. he nudges me. He's like, "Go outside." And I step out the door, and there it is above the horizon, literally a good 30 degrees of comet spanning the sky. And it's really amazing in a dark sight to see that giant tail just fanned out for all to enjoy.
Comet Hyakutake looked like a comet, like what you see as a textbook. And it was cool. We had that and Hale-Bopp, and they both were circumpolar, at least I was in Alaska at the time, and I could just sit in my apartment and turn out all the lights and look northward, and I could see the comet right out the window. There was nothing subtle about it. I mean, it was right there.
And of course, the last bright comet was McNaught. It's just we're northerners, so we didn't, for the most part, get to see it unless you were able to see it during daylight.
We missed Lovejoy.
And I think that's the thing, right? Is just the fact that if you have had a chance to see one of those bright comets with your own eyes, and you can see that trail that comes across the sky, and the colors in the tail, and you can see that second tail that you might sometimes see. It's life-changing. It's a really special event, and the fact that we're about to get one, we hope. I think all of this excitement and enthusiasm that we're seeing on the internet is really justified. That if this does what we're hoping it's going to do, this is going to be one of those events that we'll be remembering for decades now. Nicole, have you had any bright comet experiences?
Hale-Bopp was probably my first and really only good bright comet experience. I didn't see the tail because I lived in New York City at the time, but it was the first time there was a major astronomical event on the news that I could see from my light-polluted street, which was awesome. So that one definitely sticks in my mind. So I'm excited for this too.
I think Comet Holmes in 2008 was the last naked-eye comet I've seen when it went into outburst in 2008.
Was that? I think I saw that one. Yeah.
Yeah, we all missed Comet Lovejoy because it went south, so we had to watch it on the internet. But
and what's so spectacular about this one is it's currently hanging out in the ecliptic, so it doesn't matter if you're a northerner or a southerner, as long as you're not too far north or south. Everyone in the middle, which is most of us, are going to be able to see this comet do its thing.
It's going to be amazing. So Pamela, you've been, as you mentioned, you were up at an observatory when you got a chance to see Hyakutake. What is it like to sort of like what process is it for finding these comets in the first place? How do astronomers find these things?
The process for finding comets, asteroids, many of these moving targets is straightforward. You take image after image after image with a telescope that doesn't even have to be a big telescope, because your goal is to get a large field of view and observe it very, very precisely. So you want to not have a lot of variation, not have a lot of hot pixels, and you take one image 1 week, take another image either a few days or, depending on the speed of the object that you're looking for, a few hours later. You subtract those two sets of images and you look for the stuff that's moving. This exact same technique was used to find Pluto. It's been used to find Kuiper Belt objects. And we also use it to find the things in the inner solar system. And we do this on a regular basis with many different nations having networks of telescopes set up to do this, because well as finding these gorgeous comets, they also periodically find things that cross the Earth's orbit a little too close for comfort. So far we haven't found anything destined to hit us, but the worry is there's something we haven't found out there, and we want to find it well ahead of time.
Oh, yeah. So, I mean, you've been involved in the citizen science, in the amateur community. So what is the role that amateurs play in finding so many of these comets?
Well, with objects like this that aren't where you expect comets and asteroids to be, they're the ones who are out there looking in the unexpected parts of the sky. Most objects in our solar system lie, from our perspective, in a narrow band. They lie in the constellations of the zodiac. You can see all of the planets in that same band. It's the part of the sky the sun passes through. And this is because our solar system, for the most part, is pancake-shaped, or more like a plate of, well, not necessarily flat pancakes. But very occasionally you get these comets that come from the Oort cloud, which is a sphere of icy chunks that surrounds our entire solar system. And for reasons that we don't fully understand, gravitational interactions between different objects out there will cause something to come flying our way. And these objects aren't confined to that set of pancake orbits. So in this case, we have something that's coming in and sweeping through in an orbit that just cuts straight through the set of pancakes. The surveys that are looking for near-Earth asteroids, looking for the objects likely to hit the Earth, they're confining where they view, for the most part, to this, well, ecliptic, to this area of the zodiac on the sky. Amateurs are taking up the slack and looking high and low to the north and south, and finding these objects that are more on polar orbits.
Now, Nicole, you're a radio astronomer, and I know that the radio astronomers have a role in this as well. Mm-hmm. So, what kinds of observations get done by some of the big observatories and some spacecraft, and even the radio observatories when these kinds of objects have been discovered?
Sure. So unfortunately, we couldn't have Sandy Springman with us today. She is an she's an operator at the Arecibo Telescope Radio Observatory, and so she sent along a spectra. So what these radio telescopes can do is look at the break up the radio light into by wavelength, kind of like very roughly like you would with a prism to make a rainbow, but done electronically with a radio telescope, and look for absorption lines of molecules, specific molecules in the comet. And so they sent this one along to share, and it's a little bit of a messy spectrum. Let me see if I can screen share this quickly. And this is looking specifically for OH, I think, so a hydroxyl. Can you guys see that very messy, lovely spectrum?
Yeah, I see.
Yeah.
Is what they sent along. So there's a as I said, they don't even have units on the graph yet, but you can see a dip where this OH molecule is absorbing some of the light. And so that helps us tell what comets are made of. Let me unscreen share. Woohoo!
And speaking of what comets
Pamela,
are made
you're muted.
Oh, Pamela's muted, yeah.
Sorry. New controls.
Yeah.
So one of the awesome things about this particular comet is the images that we're seeing right now are this fabulous shade of green. And a lot of people look at green and they think that it's probably from some sort of a carbon-nitrogen molecule. But in this case, it's just a carbon-carbon molecule. So we are seeing in the coloration of this comet, what it's made of. It's glowing with carbon, which is kind of awesome to think
It's not
about.
kryptonite.
No, it's not kryptonite.
So Nicole, do you want to do your demonstration? Because I think
Sure.
this is great before the dry ice.
Oh, it's fine. I have a proper doer phone
Yeah, that was very
thingy.
cool.
So this is one of my favorite astronomy demos, and it's been done all over the place, but yeah, it's fun. It's great. And this is making of a comet with mostly simple household materials. And so I get a plastic baggie, usually gallon size, to mix everything in. And then I get some dirt. So the interesting thing to note about comets is that it's made of the same stuff, pretty much, that we have around us on Earth. It's made of the same stuff that formed the Earth in the early solar system. So I have some dirt here. I just grabbed some potting soil.
The solar system doesn't have the styrofoam bits in it to retain moisture.
No. I have actually done this, like scooping dirt out from probably well-manicured lawn. Sorry. That has happened. So we have dirt. And let me open up my water bottle. There is, of course, we talk about the ice in comets. And so we have some water to start with from my actual water bottle. And at this point, I ask people to tell me, what is it in the bag we have right now?
Mud.
We have mud. Very
exciting.
What's ironic is that water, Nicole, may have actually come from a comet.
Exactly.
We're just recycling.
We're recycling that water. Okay. There are a couple of other things. So, for example, you have ammonia in comets, ammonia we see. And so I usually grab some kind of window cleaner and spritz a bit of that in there. So now we have slightly clean mud, I guess. And then there are organic molecules. So a lot of the molecules that make us up, the simple versions of them may have come from comets as well. And I have a very sticky bottle of corn syrup that I've clearly not packed well after doing this demonstration. So I put a little bit of corn syrup or soda or something like that in there to represent the organic molecules. Ew! As I get corn syrup all over my desk.
And this is why she's using her desk and not my
cool.
desk.
Right.
That's why, okay.
Can't make a comment without ruining a few desks.
It's fine. I have mud all over my desk now. Okay. So the special, fun, awesome ingredient, of course, is dry ice. And I, like I said, yes, I do take some from the chemistry department here if you can't get it from a grocery store. Crush it up into a powder as much as possible. And be very, 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 very careful in handling dry ice. You do not want to handle this with your bare skin. It can give you a nasty, nasty frostbite. But I'm going to scoop it out with the cup first. Actually, I'm going to put my...
You should be wearing a glove at this point, but she's a trained professional.
Sure, that's it. Also, never, ever, ever put it in a sealed container, because as it sublimates, yes, especially a glass container. Ahem, people. Had this happen once. Okay, so...
But the basic ingredients of the stuff she's mixing is the ammonia is nitrogen and hydrogen mixed together. Water is oxygen and hydrogen. Dry ice is carbon. So we're sticking to just plain old simple molecules except for the dusty bit. And so you can see the bulk of what we deal with in our solar system is carbon, nitrogen, oxygen, hydrogen, all frozen together in a cloud-making slurry.
Frozen together like the dust in this in this bucket. All right, let's see how this goes. I may have put too much dirt in there. So instead of waiting for millions of years for these particles to come together and coalesce as they would have in the early solar system, I just add a bit of pressure and I squeeze the bag. I said I'm not sealing it, but I'm squeezing it. And this is the part where gloves are very handy. And
What's awesome about the dry ice is at the pressure on Earth, it goes straight to gas. There's no melting into a liquid, no runny mess, just straight into a air you can't breathe.
yeah, which is really fun when I'm scooping it out of the big container in the chemistry department. All right. Oh, I think I have myself. Oh, this breaks apart on my keyboard. I'm gonna be really sad.
It amazes me when you hear how many millions of tons of material comets lose in a second or so.
Look at this comet.
Yeah, comets. So it's actually a very dirty snowball. This is probably dirtier than I usually make it.
Oh, cool.
But the dry ice chunks in there are still sublimating, and so at this point you can blow on it, make little bits of gas sublimate off faster, explaining that as I warm it up, I have metal of my keyboard. As I warm it up, this is causing sublimation, and as it gets close to the sun, that warms it and causes sublimation, which creates the tail. I will also run around with this, yelling, "I'm a comet! I'm a comet!" in an elliptical orbit around whatever room I'm doing this demonstration in, which people seem to love. So there is your physical analog of a comet.
Now, this comet's actually very, very different from ISON. One of the really perplexing things that astronomers are struggling with is as we watch Comet ISON with our eyes, telescopes that are looking in the color green, it's getting steadily brighter and brighter and brighter, exactly the way that we'd expect. And this is because we're looking mostly at the color of the gas and how it's reflecting sunlight. But if you look at the exact same comet using a red filter, looking at it in colors that correspond to the dust reflecting the light, it's not getting brighter. So it seems that for some reason this comet just doesn't have the cloud of surrounding dust that we'd normally expect. And so this is making a lot of people wonder, is it going to have the tail we'd normally guess? How is it that this comet is going to vary? We don't know what to expect. This is a virgin comet. It's never passed through the solar system before. And everyone's guess varies. There is a paper out there that is saying there's 100% probability that this comet is going to self-destruct on November 28th on its closest approach to the sun. And there are other people saying, no, it's going to be just fine. It's going to come out the other side and appear absolutely spectacular.
We actually have a few people taking bets in the YouTube comments right now. Not that I encourage gambling, but that is happening.
We should totally have a pool, and then, you know.
There was an interesting discussion out of the 45th DPS meeting a few weeks ago that I wrote an article on, that actually they're kind of bumping up their chances of it surviving perihelion. They're saying that for the distance it's passing the sun at perihelion, that seems like 200 meters or so for the nucleus is the magic cutoff size. And everything I've seen for the estimates of ISON, we still don't know exactly how big the nucleus is, but the low end of what I've seen is 0.5 kilometer up to about 3 kilometers. So it seems like, but again, it's hard to tell how well that's put together, and it's never been in the inner solar system. So, yeah.
Well, yeah, I wanted to talk a bit about sort of the future and sort of like, you know, we've talked about where it came from, how it was discovered, and sort of what it's made of. And now I want to talk a bit about what's going to happen in the future. And David, so, you know, from today, we're recording this on November 1st, 2013. Yeah. We still haven't hit perihelion. So what are the next couple of weeks and months going to play out like?
Right now, amateurs are just getting their first looks with backyard telescopes. There's people who've been imaging it for the past few weeks. It passed very near Mars and Regulus recently, a few weeks ago. They got some pretty good images. The MSL rover, I believe it was MSL and MRO, got some okay images of it. They're not really meant for imaging night sky objects. I got my first look at it about 2 weeks ago when it was near Regulus. It was about 10th magnitude. It wasn't a really bright object. Comet Encke right now is actually brighter. That one is there's actually a few comets in the morning to look at. ISON will be taking center stage over the next week. I think a red letter date's going to be when it passes the bright star Spica on November 18th. It's going to pass within 0.5 degree, which the full moon is 0.5 degree wide. So it's going to pass closer than that to that bright star. So Spica in the constellation Lyra, in Virgo, is actually going to be a good guidepost to find ISON at that time, and it may be approaching naked eye visibility around the 18th. It's going to brighten very rapidly. One thing right now is we have the moon has been in the sky the last few weeks, but the moon is going to reach new on Sunday, so it's going to be moving out of our morning sky, so we're going to be able to do some deep sky observing once again. We've got a good 2-week window coming up before the moon reaches new again and comes back into the morning sky.
And so then it's going to be, it's moving past Spica, and it's going to hit that, when's the perihelion date? When's that date when it gets the closest to the sun?
U.S. Thanksgiving on the evening of November 28th. We'll probably all be watching SDO and SOHO. It's going to be entering the SOHO camera just a few days prior. So at SOHO's LASCO C3, we'll start seeing it. Right now, one of the NASA Stereo spacecraft is already imaging ISON. It's about halfway through the field of view, so we're seeing it there too. SDO will probably be the key place to watch it as it gets really close to the sun.
And so how close is it going to get?
Visually, it's going to be about an angular degree, about 2 solar diameters. Physically, from the surface of the sun, it gets close enough that the radius of the sun actually comes into play. It's going to be 1.16 million kilometers from the surface of the sun, which Lovejoy came much closer than that, and it survived a few years ago. I remember watching that on SDO, and we were all on Twitter taking bets when it went, because it actually physically passed behind the disk of the sun that night for about 30 minutes, and we're all like, we're not going to see it come out the other side. It's gone. And Lovejoy actually popped back out the other side and was a great comet.
Pamela, what impact, I mean, does the sun have on these comets as they make this close approach, as they make this perihelion approach to the sun? What happens to them?
Well, there's 3 different effects that you have to worry about. One is just the gravitational stability of the object. You have, as the object gets closer and closer, the pull on either side of it is actually slightly different, and if the pull is too great, it's going to get shredded. This object will probably be held together quite happily. But then the other issue is it's getting heated up, and you're talking about an object with a potentially uneven mixture of chemicals. And as these things heat up, well, they release all those gases like Nicole was showing us. So you have a hot object that's going to have jets popping out in various places, and you don't know how that's going to set it spinning. You don't know how that's going to cause chunks of it to blast apart. Comets in general are fairly fluffy rubble piles orbiting through the solar system. So far, observations of this one lead us to believe that it's a more solid object. So there's a chance that this difference in fluffiness, which is a strange word to see in science papers, but it's the one we use here, this difference in fluffiness is actually potentially going to, well, either trap gas in and make it explode more violently, or perhaps work out kind of lucky for us. One of the things that's been happening so far is it seems like most of the ice has been melting off of the one side that's facing towards the sun. As it swings around, it's going to be exposing a different side to the sun. That might cause it to brighten magnificently and keep the thing a little bit safer. We don't know. There is almost no way to predict this. It could explode due to trapped gases. It could crumble apart due to gravitational forces, or it could just merrily go on its way and do very little.
Right.
This is passing inside the solar Roche limit too. When I was writing an article, I came across that it's passing within about 1 million kilometers inside the fluid Roche limit. So.
Yeah. So I think, where this really relates to a lot of the people that are watching this is the chance that we as regular people without super powerful telescopes are going to be able to watch this. And I know, amateur astronomers around the world are turning their eyes to the skies, they're getting out their binoculars, they're getting ready. So what will people be able to see, starting from today? Here we are on November 1st. You probably want a pretty big telescope to be able to see it today and some nice astrophotography gear. How is that going to become more and more accessible over the next coming week?
Just a few days ago, I've heard of there was a observer in the Czech Republic that managed to catch it with binoculars. Again, it's not a bright object in binoculars, being between 8th and 9th magnitude right now. And plus, when you're talking about comets as opposed to stars, they have all their magnitudes concentrated down to basically an infinitely small point. Comets have that. They're kind of like when you're looking at globular clusters or galaxies, that surface brightness, the magnitude is spread out over the object. So it's just breaking binocular visibility right now. But I think the key is going to be under moonless dark skies, which most of us here in the U.S. East Coast don't have. The moon's out of the sky right now, and I think it's going to reach naked eye visibility a few days prior to perihelion. But of course, perihelion is going to be closest to the sun, so it's going to be very difficult to observe at that point. I think that week right after, if it survives, or if it breaks up after perihelion, we could have a long string of comet fragments going back out too. That's happened before, so that could be an interesting turn of events too.
And it's important to remember that this is currently an early morning object. So if you go out tonight in the early evening, it's not there. You have to drag your sorry self out of bed 5, 6 in the morning. depending on where you are in your time zone. And look right now, if you look for Mars, you'll find it. Your hand covering Mars will also cover the comet.
Yep.
To find it precisely for your location, there is free software called Stellarium. They have the orbit for ISON in the software, and go out, find out when in the morning, and if you're lazy and hate mornings, I'm with you, I get it. This is also going to be a great object to share with your family, potentially on Christmas. Its closest approach to the planet Earth is going to be on December 26th. So in the early evening, just as the sun sets, just as it's getting dark, look for the star Vega, the summer triangle that we're losing as Christmas comes upon us. Northern Hemisphere folks, you should be in for a treat. Unfortunately, this isn't as much of a Christmas present for the Southern Hemisphere.
But do you think that we're going to be able to get like that nice tail, leading up into the sky in the evening, or will it already be starting to dim by Christmas, do you think?
I think it will be dim by then. Yeah, it's the light curve I've seen. It's going to dim pretty quickly. I think that those very last days of November into that first week of December is going to be the key time to observe it if it survives.
But if you get that new telescope for Christmas.
Right. Now with the last comet that we had, it was the folks in Australia, New Zealand, the Southern Hemisphere got a much better view, and we in the was it McNaught? Was it
both McNaught and Lovejoy were Southern Hemisphere comets.
Yeah, we're Southern Hemisphere, so we in the Northern Hemisphere didn't get a view of it. This time around, though, is there going to be any restrictions? The whole world will be able to see it?
I think it's going to be more Northern Hemisphere. I think some of the latitudes, the northern, southern latitudes toward the equator will see it, but I think the far southern latitudes may miss out on this one because it's going to be going off to the northeast in the morning.
Yeah, so as early as November 26th, it's in the northern extreme of Hercules. Right now, it's you can get to it now, but you're not going to be able to get to it much longer.
Right.
And come Sunday, we'll have to get up an hour earlier too because we shift back to standard time for North America, so that's getting up even earlier.
Right.
Staying up, not as early.
So this is it. So I mean, I'm trying to give people, a way that they don't have to wake up in the early morning to see the comet. But I don't think it's going to happen.
Astronomy.
No.
This be a morning person. You have to get out there or stay up all night if you want, if that's how you roll. But get up early morning and get a chance to see it. It's going to be the way.
A very interesting date, right around December 1st, when the moon comes back around toward a waning crescent. It's going to be near Mercury and Saturn are behind the sun, but they're going to be in the very low sky about a month from now on December 1st. I think that's where you're going to see some of the best photographs because you may be able to get Comet ISON, Mercury, Saturn, and the waning crescent, thin crescent moon all in the same frame. So that might be a very cool thing to see.
Now we've been, we've been cataloging a lot of the pictures that are coming in from our readers. We've been posting lots of stuff on Google Plus, on Flickr. So what are the ways that maybe the amateurs can, the folks over the next couple of months who want to get involved, take pictures? What are the resources they can do to kind of share their knowledge and information, around on the internet? I mean, that's the amazing thing this time around. With previous comets, we didn't really have the internet in the same way to communicate with each other, but this time around it is like this worldwide collection of enthusiasts who are all coming together. They're sharing their information. This is unprecedented. So
I've thought about that. It's like it seems like every time a comet comes around, I remember we had a very close comet in the mid-'80s called Comet Iraqi-Alcock that came within a few dozen lunar diameters of the Earth. We all heard about it in Sky and Telescope a month later because that was where the technology was.
Yeah, I mean, think about that. Like in the olden days, you would see a picture in Sky and Telescope about some comet, and then you'd know that a comet had come by and there might have been a chance to see it. But now, I mean, there's just this buzz that is happening. So, I know about you guys. Like, what kind of buzz are you guys getting? You're seeing on the Twitter, you're seeing in your email, we're seeing on the YouTube comments.
Google Plus. That's where I'm seeing it because we have the ability to socially share our images up there, get the words out, And the awesome thing about using Google Plus is it's the type of place where you stick your pictures, write your article, and then you relink from Twitter and Facebook. So do all the things, but there's always great places to keep up with the pictures. Universe Today, Space.com, Space Weather, all of these places are currently collecting some of the best photos and pushing them out there for everyone to
we've
enjoy.
got a pool. We've built a pool on Flickr called the Universe Today Photo Pool, and we've got about 10,000 images in there so far. And we constantly pull images, and we post them on Universe Today. We tweet them out. We repost them on Tumblr. So we're sort of, if you want, like, there's lots of places, lots of great forums. Ice in Space is a great forum. But if you want a place that if you're taking some pictures over the next couple of months and you want to share them with us and then let us help sort of get the word out, definitely check out that. And you can access that from Universe Today. There's like a photo tab on the top, and we can sort of help get that information out. And we're glad to sort of compile them and reshare them. And if you've been taking pictures, that's the best thing ever.
I just saw a really nice one on the CosmoQuest Bad Astronomy Universe Today forum. We have a astrophotography subforum where members have been posting really gorgeous pictures, and I just saw a really gorgeous Comet ISON picture posted by one of our members. So I'm kind of watching that.
Oh, great! Well, share some if you see them.
Yeah.
Now, Nicole, when you sort of took your astronomy degree, radio astronomy, you had to do a lot of like math and geometry and learn how to find these objects in the sky. So do you find that sort of this and other kinds of events, as we're trying to explain, has that been sort of increasing people's interest in geometry, in learning the night sky and the coordinate systems, things like that?
It might be less so learning the geometry and the math behind it, but more wanting to learn about just how to use a telescope practically. I got a lot of, like you said, I was a radio astronomer professionally, but doing outreach, it's all been optical, and so I've had to learn, now that I no longer live in a big city, how to actually use an 8 and 10-inch telescope. And so, what was the one in 2007, 2008?
McNaught?
McNaught?
Was it McNaught? Okay, that one, I found with one of our 10-inch telescopes at the University of Virginia and showed it for a public night, and I was so excited. And people, it's good because you can get people to come to public events if they don't have the nice shiny equipment that they can look at it themselves with. If this one's going to be bright enough to see naked eye, that's not a problem, but it's good to seek out your local observatory or local amateur astronomy group and have them help you find it or show it with their equipment. I'm actually debating whether or not I want to have an early morning public observing session. We gotta see what the interest is.
We're talking about doing that here at our Starkey Park group, about doing a morning observing section if ISON is a good comet that we might, if we get the interest for.
But I've found that just the general conversation that I'm having with people now, about positions and perihelion and positions and distances and this kind of stuff, that people are really starting to understand the solar system in a much better level, I think. It is a good steady on. When we had Hale-Bopp and Hyakutake come by, it was interesting. We had a small comet close up and a large comet far away, so there was kind of a good contrast between the two. Maybe we'll have another small one come out of nowhere. That'd be kind of cool to see.
We're actually getting a couple of questions on the YouTube channel.
Yeah, let's take some questions.
Exactly relating to this. So people talking about the orbits. And,
do you want to try and put the question actually into the stream, Nicole?
No, because Comment Tracker is not working.
Oh well.
But I've pulled these two out of YouTube. One of them is by R.D. Brewer. He's asking, or he or she is asking, why are all comets and asteroids doing about 35,000 miles an hour?
Whoa, good one, Pamela. I'm gonna fire back.
Well, it's not that they're all doing that. It's that the ones that are on Earth crossing orbits tend to have about the same velocity because they have very similar orbits. Comets are going to be going radically different speeds depending on where they are. And this all has to do with Kepler's law of objects sweeping out equal area in equal time. So they're going to be going one rate as they're far, far away from the sun, and as they come in, they're going to whip past very quickly. And it just happens that things that all have similar orbits, as they cross the Earth's orbit, due to this equal time and equal areas part, they're going to be moving the exact same rate, or same rate relative to what they're doing.
But the speed of their orbit actually does change as they get closer to the
Yes.
sun, and then as they're moving away again. So.
And often what you hear quoted is the orbital speed on closest approach to the Earth, or the orbital speed on closest approach to the sun. If you're always talking about how something's going as it's closest to the Earth, well, it's always going to be about the same distance from the sun and moving at very similar velocities.
And we
That's
have
cool.
a question also from Eric Williams, which was partly answered by some of the other commenters, but I would like to put it here. Does a comet passing through change the orbits of asteroids at all as it goes through the asteroid belt?
I do know Jupiter can alter a comet's orbit frequently.
Oh, so Jupiter can alter the comet, yeah.
Yeah. I think I saw a statistic about a comet coming in the inner solar system has about a 40% chance of having its orbit altered by Jupiter. And of course, we had Shoemaker Levy 9 hit Jupiter back in the
Yes,
90s, so that was
dramatic.
very interesting.
And the thing to remember is it's not Han Solo's asteroid belt. Our asteroid belt,
Or Star
for the
Fox.
most part, is very empty. And sometimes we get lucky. So, for instance, if you go out next week, November 7th, you're going to see Comet ISON and the asteroids Ceres and Vesta all very close to one another on the sky. But
Cool.
that's on the sky. They're very different distances from the sun. And it's this difference in distances from the sun that means if you're standing on Vesta, you're not going to be able to see Ceres just by looking out there. And if you're trying to fly through the asteroid belt, you actually have to try very hard if you want to hit something. So asteroids are tiny. Comets are moving quickly. Gravity isn't what you have to worry about. Direct collision at a very small probability, very, very, very small probability. That's the way it's going to have their orbits altered on a very rare basis.
Right, but I mean, comets have so little mass. I mean, they are the size of buildings. I mean, they are not going to, and some are larger than that, but they're not going to cause any gravitational interaction really with it. They're not going to pull anything out of orbit or shift anything or anything.
No, but an asteroid might have a very minor effect if it gets nailed.
Right, but more importantly, these poor comets are going to get yanked around by the sun and Jupiter and things like that.
You just reminded me something, Pamela. On November 25th, there's another bright comet in the morning right now. It's Comet Encke, which is a periodic comet. November 25th, ISON and Encke are going to be within about a degree, a little over a degree apart. Again, they're not physically close, but they're going to, from line of sight from the Earth, they're going to appear about 2 full moons apart. So we'll probably see some photos of that too. That'll be kind of interesting to see.
Send them in. Send them in. I want those pictures. That'd be great. Yeah, so pictures of the 2 comets together close in the sky. That's going to look so cool. Oh, go ahead, Pamela.
So the frustrating thing that we're dealing with right now is every day as the comet gets a little bit closer to the sun, it's getting brighter and brighter. But because it's getting closer and closer to the sun, you could only see it in the ever-brightening twilight. So it's getting brighter as the sky it occupies gets brighter. And so when it comes out the other side of the sun on the 29th or 30th of November, it's going to be right in the twilight, morning, evening, make your pick. And trying to see it is going to be extraordinarily difficult. Now, since it is heading north, it is going to become an object that you can see on both sides of the sunrise. But it's still going to be harder due to that getting closer to the sun problem.
We had that problem with L4 Pan-STARRS this spring. Is it set right there? It was a good comet, but it set right in the twilight, so a lot of people didn't see it.
Yeah.
Yeah. Did you have any more questions?
We have some plugs for the virtual star party coming from our commenters, so thank you guys.
Yeah, well, this is, definitely on every Sunday night when it gets dark on the West Coast, we hook up a bunch of telescopes into a live Google Plus Hangout. This is our virtual star party, and so it will absolutely be our objective over the coming weeks to try and bring you Comet ISON live into the Hangouts. That's going to be the objective.
I think it's interesting to think that only about half a century ago, ISON at this point probably wouldn't have been discovered yet. It's you hear about a lot of comets that they don't get discovered until they were like 6th or 7th magnitude. So we're discovering them a lot fainter and further out, which is kind of cool.
And this one, even if it does turn out to be an optical fizzle with a not particularly dramatic tail, because the sucker's not gassing nicely, it still has one potential extra show to put on for us in January, and that's when the Earth passes through, well, its path through the sky is going to go through where it was. So we're looking at a mid-January, brand new meteor showers, not quite sounding like the right word because this isn't an asteroid, but it's going to be a meteor shower. All of the flecks of material left behind as the comet makes its way across the Earth's orbit, we're going to encounter that, and so be prepared for a whole bunch of shooting stars.
And there's an app for that, even. There's a meteor counter app that's being used for a citizen science project tied with the Lottie mission to the moon. And so they're looking for micrometeorites hitting the moon, and one way you can correlate that is looking at how many meteors flash through our atmosphere. So you can get that app on your mobile phone and count meteors and help the scientists out there.
Oh, that's really cool.
That's very cool.
So I think, how do you think sort of the enthusiasm, David, for the next coming weeks and is going to go? What are you seeing right now, and what do you expect is going to happen?
People seem pretty. It seems like there's been an upsurge of optimism right after Comet ISON came out from behind the sun from our vantage point. Actually, we went from behind the sun from its vantage point. It's not near perihelion yet, but this summer we kind of lost sight of it, and then we're starting to get view of it again. It seemed like there was kind of a downtrend where people were saying it's not performing up to standards, but now it seems to be going right about down the middle of the minimum maximum for magnitude. So it seems like there's more of a surge in optimism right now. I know a lot of people, myself included, were holding back on writing our post-perihelion posts, how to observe Comet ISON post-perihelion, until we kind of get into that week to see what it's going to do. I think it's either going to, if it breaks up before perihelion, that would be a very bad thing because it would totally fizzle like Elenin did a few years ago. If it breaks up, during or right after, we could be in for another show too, where, like I said, we would have that string of comets, or Comet Lovejoy was kind of that headless comet that went back out. So there's a lot of different scenarios.
So what's the next big date? Here we are, November 1st. What is the next big date that people should be keeping an eye on?
November 28th for people who like looking at SOHO and stereo images. Either side of that, there's going to be that moment when we can't see it because the sun is in the way. But either side of that November 28th closest approach, looking at those satellite images to find out, did the sucker survive? After that, it's just going to be a slow, gradual watch. Personally, I am looking forward to the closest approach to Earth because there's something visceral about taking people outside and looking through a telescope and saying, this comet is new. It has never gone through the solar system before. It's evening. It's all of your family who normally don't listen to your astronomy. But this time, you have something awesome to show them. And then in January, that meteor shower.
Yeah. It just passed within 1 AU of the sun, so it's inside the Earth's orbit as of today. So.
As of today? Oh, really? Oh,
yes.
That's amazing.
Yes.
That's
within
really
1
cool.
AU.
If you're an astrophotographer, there's a contest going on, speaking of dates. The National Science Foundation and Astronomy Magazine and Discover Magazine, it looks like, are co-hosting a contest. And that's due January 15th. So you have plenty of time before and after closest approach to the sun to take your best shots and submit it to this contest. I can put the link somewhere if needed, the event page.
Sure, that sounds great. Cool, okay. Well, I think we're sort of running to the end of our hour now, so why don't we start to wrap things up. So I am going to give a big thank you to David Dickinson. Thanks, David. And where can people find out more?
I am AstroGuys with the Z across all platforms, on Twitter, on my own site. Right this week I was active on Universe Today, Listosaur, Canada.com, and I will probably be chasing after the partial solar eclipse this weekend from the Florida Space Coast to watch the eclipse rising. We won't get a total here, but I'll be driving over there to maximize my chance of maybe get the VAB behind the partially eclipsed sun.
Oh, that's going to be cool.
Yeah.
Dr. Volgalucci, where do we find out more?
Oh, I live at cosmoquest.org. I work for CosmoQuest, and I'm also a noisy astronomer on Twitter and everywhere else on the interwebs. So.
You are everywhere on the interwebs. Dr. Pamela Gay, where do we find out more?
I am also at CosmoQuest, but then of course there's Astronomy Cast where you can find both you and I every Monday, and we will hopefully be going live Monday afternoon with a talk on the sun, so you can find out more about how all these different layers of the sun are going to try and suck the life out of Ison. And then I'm Star Strider on all of the interwebs.
And so here's the thing. If this turns out as great as we hope, then let's come together again in another month and a bit, and let's do the actual, if it's actually that great and people are able to get a chance to see it, let's give people some observing tips and give people a big update maybe in about a month from now if it's all
That
happening.
sounds great.
Cool. Sounds like a plan.
Good? All right, that sounds great. Well, thanks everyone for watching. Really appreciate it. As I mentioned, this is going to be part of a special with Discovery Channel Science. It's going to be on December 4th, 2013. So if you miss it here, you can watch it on TV later on. So, but there's going to be a whole bunch more stuff in this special. So it's going to be really great. So thanks again for everyone for watching. Thanks to the panel for joining, and we'll see you all next week.
Thank you, Fraser.
Stop broadcast. And and lots of comments on all the posts, and a lot of stuff that we want to clear up. So this has been fantastic. We got Dr. Nicole Gallucci.
Hello.
Hey, Nicole.
Oh, wait. Here we go.
This is great.
Oh, very cool.
This is cool. So you are going to be showing us how a comet is, how to make a comet.
How to make your own little comet you can hold in your well-protected gloved hands. Yes, we'll be doing that.
If you have a chemistry department at the university that you can raid.
Or you can just go buy dry ice.
Not
Just
here.
don't ever put it in your freezer. If you put it in your freezer, it will freeze your freezer and break it.
Yes. I discovered you cannot buy it in the grocery stores in this town, unfortunately.
Really?
Yeah,
We
but
used to
most
get it-
places I've lived, you can buy dry ice in the grocery store. So.
But you can buy it. Okay, yeah, we used to get it in like ice cream cartons. We get a box with a bunch of ice cream and there's some dry ice in it. So this is going to be great. And we've got Dr. Pamela Gay.
Hello.
My co-host on Astronomy Cast and the director of CosmoQuest, professor at Southern Illinois University, Edwardsville. And you, of course, know all things comets, and so you're going to be helping us out today as well.
I'm bringing the science.
Bring the science. All right, so as I mentioned, it's going to be all things. It's going to be ISON all the time today. Oh, I lost my my overlay. Let me bring myself back.
Oh no.
Yeah. Right. So it's going to be all things ISON all the time. Now, there's even cooler is that we are filming this, recording this, broadcasting, hangouting this live from the H.R. MacMillan Science Space Center in Vancouver, British Columbia, which is my hometown. And this is my local planetarium. So this is the one that I came to as a kid, and it's really awesome that we're able to do this here. And so hopefully we're going to get some cool shots of the planetarium later on today. So, as always,
it's cool.
they've got the new Hangouts. Okay, so everyone, so we are now live in 3, 2, 1. I apologize, everyone. There's a whole new way of doing Hangouts now, and we're still trying to figure this out. So, well, hi, everyone. My name is Fraser Kane. I'm the publisher of Universe Today, and this is a special episode of the Weekly Space Hangout. This week, we are dedicating our entire show to Comet ISON. And this is sort of part of a larger project, actually, we're doing with the Discovery Channel. They're doing a special, Discovery Channel, Discovery Science in the United States and Discovery Channel Canada are doing a big special on Comet ISON that's going to be broadcast on television on December 4th, 2013. And as part of that, we're going to be incorporating our Space Hangout into this and sort of the show we're going to be doing today, and a lot of other really interesting stuff. So keep your eyes peeled for that, and we'll be giving you more information. So joining me for this very special episode of the Weekly Space Hangout, we've got David Dickinson.
Hey, I'm ready for all ISON all the time this month.
All ISON. Well, it's been all ISON all the time for you for months now.
Even more so, I think.
Yeah, yeah. This is going to be the big month. I know people are getting really excited about ISON. We're all getting deluged with emails and calls